Hello, classmates. The circuit diagram is composed of ideal electronic components. In order to analyze the characteristics of the circuit conveniently, we must first master the characteristics of basic ideal components. The basic ideal components include resistors, capacitance, and inductance. Today, let's get to know resistors first. The substances in nature, according to their conductivity, can usually be divided into conductors, insulators, and semiconductors. Conductor is a kind of material with strong conductivity. The physical quantity that measures the electrical conductivity of a material is called resistance. Resistance impedes the flow of current passing through it. Not only metal conductors have resistance, other objects also have resistance. The conductor resistance is determined by two factors. The first is the electrical conductivity of the conductor material. The second is related to the size of the conductor. To calculate a relatively large resistance, we can use kiloohm or megaohm. For example, 1 megaohm is equal to 10 to the power of 3 kiloohms and is also equivalent to 10 to the power of 6 ohms. Due to the law of conductor resistance, at a certain temperature, the resistance is proportional to its length, and it is inversely proportional to the cross-sectional area. Let's familiarize ourselves with the law of resistance in the form of examples. As shown in the figure, determine the resistance of this bundle of wires, we can apply the formula of the law of resistance. Substitute the given data and perform calculations. The calculated resistance R is 4.35 ohms. The material carriers of different materials, when passing through the same current, show great differences in resistance. Under normal temperature conditions, the resistivity of different materials varies. We can refer to or consult the table in the diagram, showing that there is little resistance to current, and exhibiting good electrical conductivity, such as copper, aluminum, and etc. Common methods of marking resistance values include the colored ring method and number method. There are many kinds of resistors in real life. Classification methods are also diverse. The figure shows several commonly used resistance products. The lower part of the picture also shows us photosensitive and pressure sensitive, and thermistor and other special resistors. Resistance is an important part of electrical technology. It is also one of the most used components. The main function in the circuit is to limit current and divide voltage. The following figure shows the volt-ampere characteristic curve of linear resistance element, where the ordinate is the voltage of the resistant element. The abscissor is the current of the resistance element. The volt-ampere characteristic curve of linear resistance elements is a straight line in the voltage-current plane, passing through the coordinate origin, which can usually be denoted as R equals U divided by I, representing that under the condition that voltage and current have a correlated reference direction. Electric power, absorbed by linear restrictive elements at any time. P equals Ui equals I squared R equals U squared divided by R. As can be seen from the above formula, the electric power P on the resistance element is greater than or equals to 0, explaining that the resistance element at any time is impossible to generate electricity. That is to say, all the electric energy it absorbs is transferred to other forms of energy, or consumed or used for other purposes. That is, the restrictive element is an energy-consuming element. For example, if we want to determine the maximum related current and voltage of a restrictive element marked 25 ohm, 225 W, we can analyze according to the formula of power. Use the formula P equals I squared R to calculate the current I. Then, according to the power formula, P equals U squared divided by R. Find out the corresponding voltage, U. To test the resistance of a resistor with an analog multimeter, the general arrangement is as follows. Place the meter directly in front of your line of sight for easy observation. Adjust the meter to the ohm position, touch the two probes together and observe if the needle moves. If it's not moving, check if the gear is set to ohm, or if the probes are connected correctly. Select appropriate ohm gear. Choose a gear that keeps the pointer within the range of 3 to 30. If it is less than 3, if it is greater than 30, if it is greater than 30, we need to shift up one gear. Zeroing. Before using the meter and switching gears, adjust the zero knob on the multimeter so that the needle aligns with the zero mark. This ensures accurate measurement data. For measuring fixed resistance, place the probes on both ends of the resistor so that the data can be read from the front to get the resistance value by multiplying the reading with the gear number. For adjustable resistors, first, measure the resistance of the fixed terminal using the above method to obtain the maximum resistance value. Then, move a probe to the moving terminal and rotate or move the adjustment knob, while observing if the needle changes continuously. If not, it may be due to poor contact with the resistor. When measuring resistance with a digital multimeter, the basic flow is the same as that of analog multimeter, with the exception that there is no need for zeroing. In addition, its detection gear is different from the analog table, requiring more accurate alignment within the range. Regardless of which type of multimeter is used, attention must be paid to the following. When measuring, avoid simultaneous physical contact with both ends of the resistor, as this can result in inaccurate measurements. And the greater the resistance, the greater the impact will be. For resistors on the circuit board, first solder one end and ensure there is no charge before conducting measurements. It is not difficult to observe that resistance, as a conductor, hinders the flow of current. The unit of resistance is ohm, and the resistant value is determined by the resistivity of the substance itself, as well as the length and cross-section of the conductor. It is independent of other factors within the actual circuit. See you next time!